exponential rules. There is about 10 of them. Before I get started, just to remind you what an exponent is. If you have something like 3 to the third power, that equals 3 times 3 times 3, which is 27. 3 times 3 is 9, and 9 times 3 is 27. So this 3 here is an exponent. So these are exponential rules, so rules that deal with exponents. And the first one is that anything to the 0 power equals 1. So that's just a rule worth remembering. I'll explain why in class, but for now I'm just telling you what the rule is. So if you had 7 to the 0 power, it equals 1. Or 9 to the 0 power, it equals 1. Anything to the 0 power equals 1. So that's the first rule. The second rule is a to the m, this is in general terms, times a to the n. So in this case, they have the same base, something raised to a power, and that same number raised to a different power. You would add the exponents, so a to the m plus n. So that's in general. I'll give you an example. If you have x to the third, and you multiply it by x to the fifth, you will get x to the eighth. So you add the exponents. And the reason for that is x to the third means x times x times x. X to the fifth means x times x times x times x times x. And if you multiply that all up, you would get x to the eighth. So you add the exponents when you have the same base. So a to the m times a to the n equals a to the m plus n. That's the second rule. Exponential rules. A times b raised to the power of m is the same thing as a to the m, b to the m. This is sort of like distributing. So for example, if you had y to the third and you squared the whole expression, you would get y to the, oops, is that the example I wanted? Wrong one, sorry, that was the wrong example. If I had 4x to the third, that would equal 4 to the third x to the third. So I'm distributing this exponent to each term, and 4 to the third is the same thing as 64 x to the third. So I'm sort of distributing this to both. Same thing here. Okay. A to the m raised to the nth power is a to the m times n. An example of that, this is the one I was trying to do a second ago. Y cubed squared is equal to y to the 6th power. So you're just multiplying m times n in this case. This is called a power to a power. And the reason for that is y to the third squared means y to the third times y to the third, which if we go back over here, same base, you add the exponents, so this would be y to the 6th. Okay, so those are all powers dealing with multiplication, multiplying here. This is a power to a power, so you're multiplying. So this next example is just sort of putting it all together. So this is a to the third times b times c squared, all raised to the 4th power, times b squared times c raised to the 3rd power. So using all these rules kind of combined here, this one you'd have to distribute these powers right here. So you get a to the 12th, b to the 4th, c to the 8th, times, and now I'm going to distribute this power, b squared c to the 3rd. And now I can combine like terms, anything with the same base, you add the exponents. So I have a12, b4 and b2 makes b6, c8 and c3 makes c11. So that's a combination of using this rule and this rule, and this rule as well. Okay, so all three of them, that's in that problem. So that's 1, 2, 3, 4 rules. So we have 1, 2, 3, 4, 5 more. A to the m divided by a to the n is equal to a to the m minus n. Oops, minus n. A to the m minus n. M minus n. So that's different than this rule up here where it states if you're multiplying, you add the exponents. Here we're saying if you're dividing with the same base, then you subtract the exponents. I'll show you an example of that. 6 to the 5th divided by 6 to the 3rd is equal to 6 to the 5 minus 3, or 6 squared. And the reason for that is if you had 6 to the 5th, that's 6 times 6 times 6 times 6 times 6 over 6 to the 3rd, which is 6 times 6 times 6. You could cancel 6 divided by 6 is 1, 6 divided by 6 is 1, 6 divided by 6 is 1, and you're left with 6 times 6, which is 6 squared. So that's the reason that we're doing subtraction here, 5 minus 3. Okay, so that's another rule, a to the m divided by a to the n equals a to the m minus n. A divided by b, all raised to the same power. This is the same thing that's happening here. Nope, here, sorry. You're distributing m to each term. Same thing here, you're distributing m to each term. So it's a to the m over b to the m. So that's pretty straightforward. So if you had 3 over 7 squared, that would be 3 squared over 7 squared, and that's 9 over 49. So just distributing it to each term. And these last ones are a little tricky. This is a to the negative n. I'll explain this one a little more in class as well, but for now I'm just giving you the rule. A to the negative n, when you have a negative exponent, it produces fractional answers, so you end up with 1 over a to the n. So an example of that would be 3 to the negative 2 is the same thing as 1 over 3 squared, or 3 to the positive 2, which is 1/9. So a negative exponent produces fractional answers. That's important to remember. If the negative exponent is in the denominator, 1 over a to the negative n, then you would just, the same way this became a fraction, this fraction would be undone and you'd get a to the positive n. So an example of that would be 7 over x to the negative 2 would equal 7, and you would bring this up x to the positive 2. So it starts out with a fraction with a negative exponent, becomes a non-fraction with a positive exponent. Okay, so if you have a negative in the exponent, it produces a fractional answer. Unless it's already a fraction, then it goes back to being a whole number answer. And the last one, I'm going to squeeze it in here. A over b, this is sort of a combination of these that are going on here, raised to the negative n is the same thing as b over a. I'm just flipping this over to the positive n, which is b to the n over a to the n if you distribute it to each term. Okay, and you could do the same thing with numbers. So if I had 3 over 2 to the negative 2, that's the same as 2 over 3 to the positive 2, which is 2 to the second, 3 to the second, which is 4 over 9. Okay, and that's all the exponential rules. So let me just double check how many we had here. There's 1, 2, 3, 4. That's just an example. 5, 6, 7, 8, 9. So there were 9 of them. I thought there was 10. Okay, so hopefully you took notes on that as I was going through. If you didn't and I went too fast, just go back, play the video again, and watch it one more time. Take some notes. Make sure you understand these.